Now move on to cumulative frequency curves. The example we have is a certain librarian wanted to find out which age groups visit library more often. She was planning on buying relevant books for them to replace the old books on the shelves. Or rather order, not really buy, but order more books. The following histogram shows the data she got from her records. The first question says, so what you're seeing from the histogram there, that's the white histogram, that's basically the data. So you just analyze, it's already represented. So what you now need to do is to use what was represented to also represent again. There are reasons why you may need to put it as a cumulative frequency curve. You maybe want to find the quartiles like we're going to do later on. So with the first question, compute the total number of people who visit the library regularly. And then what is the mean age? Then draw a table of group data from the histogram. So using the histogram to draw the table with all those columns stated and probably more. Using the table in C, draw a cumulative frequency curve to represent the data and use the curve to determine the quartiles and the median, or to find the quartiles and the median. So basically you're using that histogram to do all that. And then the axis, we have the age in years on the horizontal axis, and then the frequency density. Frequency density is the quotient of frequency over class width. Basically frequency divided by class width is equal to frequency density. What else may you need to know? Okay, then we have the class width. We can see how broad the rectangles are compared to the bar graphs. Yes, they are now broad and some are not broad, they are narrow and all that. The differences of those ranges of ages which are covered by each and every let's call them rectangles. Yes, each and every rectangle represents the class width. How broad they are is the class width. Okay, so the total number of people who visit, remember frequency represents the amount of occurrences. So it's basically the number of people. If we add the frequencies, we then get 268. That's the total number of people. So we have 40 people in the first with the first range of ages from 0 to 10. And then from 10 to 30, we have 100 people. From 30 to 40 years, we have 32 people. From 40 to 70, we have 66 people. That's basically how we do it, and on and on. And then we then draw a table with the age in years. The median is X. The median is basically the difference, or rather, the sum of the upper bound and lower bound. The lower bound is, in the first case, it's 0, and then the upper bound is 10. The next case, it's the lower bound is 10 and the upper bound is 30. In the next case, the lower bound is 30, the upper bound is 40. So the sum of the two, so if you say 0 plus 10, you get 10 divided by 2, it becomes 5. That's your median. 10 plus 30, that's 40, divided by 2, that's 20. So it's basically the number in the middle between the upper bound and the lower bound. So the expression will be upper bound plus the lower bound divided by 2. Then get the median. And then we move on to the frequency. The frequency, like I said, that's the number of people, so we already calculated that. Then the frequency density is the frequency over the class width. The class width, like I said, if you look on the histogram, how thick or how broad the individual rectangles or individual bars are determines the class width. So from 0 to 10, that's the class width. So it's the difference between the upper bound and the lower bound. So 30 minus 10 will give you 20, as you can see. Then 70 minus 40 will give you 30. 100 minus 70 will give you 30. So the class width is the difference between the upper bound and the lower bound, which is basically the thickness of the rectangle or the histogram bars. So to get the frequency, we basically say frequency density multiplied by the class width. It's the product of the frequency density and the class width. So we see the first case, 4 times 10 will give you 40, 5 times 20 will give you 100, 3.2 times 10 will give you 32, 2.2 times 30 will give you 66, as you go on. 1 times 30 is 30. And then the cumulative frequency is how much more of the frequency increases as we move from 0 years to 100 years. So at 0 to 10 we get 40, but from 0 to 30 we then say 40 plus 100, we get 140. Then from 0 to 40 years we say 140 plus 32 will give you 172. From 0 to 70 years we have 172 plus 66 will give you 238. From 0 to 100 years we have 238 plus 30 will give you 268, which is basically the amount of people that visit. The n that we found in A will be the last figure that you should get. If you don't get that figure, then there's something wrong. You should the cumulative frequency should end with the total number of people or the total number of occurrences, or the total number of frequencies, you see. So when you add all the frequencies, it should add up to that last number, which is 238 in this, or 268 in this example. So that's how our table looks like. Maybe if you want to be experimental, you may add more things, but these are the crucial figures that you need for now. And this might take you a lot of time to create, but it's worth creating so that you can plot your cumulative frequency curve